Hello everyone. I hope all of you are doing really well, and this is basically the fourth video of the ACE board exam series which is in our channel Chemistry at Your Fingertips. So first of all, welcome to Chemistry at Your Fingertips. This is the second chapter. So I hope you found the content useful in the past three videos wherein I discussed the end of the textbook questions from the chapter on halogen derivatives of alkanes. Okay, so today we are going to start with the next organic topic, that's organic hydroxy compound, alcohol, phenols and ethers. And I have already told you how you should study this particular topic. Okay, so today we are going to discuss about the part 2 of this particular chapter, right? So I think this is basically the next part, that is part 2 of alcohol, phenols and ethers. Okay, so let's begin one by one. Now, the first question says, write the name of electrophile which is there in this particular reaction, that is Kolbe's reaction or Kolbe's reaction, whatever you pronounce it. Okay, so now let's try to begin understanding what is a Kolbe's reaction. This is basically a one mark question, so you don't need to explain too much, you just need to understand what exactly is this electrophile over here. But I have to explain each and everything. So Kolbe's reaction or Kolbe's reaction, in Kolbe's reaction you will be having a phenol, right? So this phenol on treatment with carbon dioxide, which you call it as dry ice, okay, and in this case we are going to use aqueous NaOH, right? So in this case you will be getting salicylic acid, right? So let's not get into the entire thing of this particular reaction. Let's try to answer this question to the point. Now, which is basically the electrophile. So we already know what is electrophile. It's going to be electron deficient species. So when you talk about carbon monoxide over here, what happens is a very simple thing. Carbon is more electronegative, right? So what's going to happen over here is, this oxygen is going, carbon is less electronegative. I'm sorry if I have told more electronegative, right? So carbon is less electronegative than oxygen. So oxygen pulls the electron pair, carbon gets delta negative, this gets delta positive. So this carbon is basically electron deficient and it is nothing but electrophilic carbon. So it's an obvious thing. This carbon dioxide is basically the electrophile that is in this particular reaction. Now let's see how the reaction actually goes, right? So initially you get the sodium phenoxide ion, right? So you know this H and this OH goes in the form of water. So you will be getting O, and O with a negative charge and Na with a positive charge, right? So for my convenience, I'm just shifting the position of double bonds or the pi bonds. Okay, so I'll have a double bond here, double bond here, double bond here. So now what happens over here is, when you talk about this oxygen with a negative charge, it's going to have three lone pairs, right? So the lone pair is going to shift here, and these two electrons, that is the pi electrons, are going to come out, and this is going to attack the carbon dioxide molecule. This is delta positive, right? And you already know this is delta negative, as a result of which the product is going to form, right? So this is basically the electrophile. Okay, this is basically the electrophile that we are actually talking about. Okay, now in this particular picture we have this Kolbe's reaction. I've already put this as a separate slide because my videos, now these set of videos are completely centered around how you should answer a particular question or what is basically the solution. So I'm just trying to avoid discussing too much about any particular question because I just want to directly give you the answers to these particular questions. Okay, so I hope the answer is pretty much clear. The electrophile which is there is nothing but the carbon dioxide molecule. Okay. Yes, so let's move on to the next part. Why is phenol more acidic than ethyl alcohol? Okay, now this is a very simple question. Phenol is more acidic. Now let's talk about phenol over here, right? So you have this phenol. in which there is this oxygen containing two lone pair connected to hydrogen. Now, when it is treated with a base like aqueous NaOH, right? So what happens? This proton is removed. It gets deprotonated because this is an acidic proton, right? And as a result of which you have this phenoxide ion. Okay, so this is nothing but the phenoxide ion. Now, if you could see here, this phenoxide basically has an n-pi resonance. N-pi conjugation, right? So there is this lone pair N and there is pi conjugation, right? So what happens? This is basically stable due to resonance. Okay, stable due to resonance. So that is the reason you can simply say that this phenoxide ion is formed, right? So that means the reaction is basically pushed towards the right, resulting to the formation of phenoxide ion and releasing the H plus, right? Releasing the H plus. So the ultimate reason is phenoxide ion is stable due to resonance. Now, if you could see here, there are certain pictures which I've already shown on the screen, which actually tells you the n-pi conjugation and the different resonance structures, okay, of phenoxide ion. Now, let's talk about alcohols. So let's take a simple alcohol, maybe ethanol. So you have CH3, CH2, and there is this OH, right? So let's say when you have this NaOH reaction with NaOH, basically nothing is going to happen. But let's say if water molecule is released, okay, so I'm just going to write minus H2O. So I'm going to write here CH3, CH2, and then O minus. So if you could see here, this is the ethoxide ion, right? So this is the ethoxide ion. So this ethoxide ion, in this ethoxide there is basically no resonance. So that means the stability is less. Moreover, you have a negative charge on this particular oxygen, and if you could see here, these are the plus I groups, which are actually increasing the electron density on the ethoxy oxygen, because of which the stability is reduced. Okay, so the simple answer to this particular question, why phenol is more acidic than ethyl alcohol? The reason is very simple. Phenoxide ion is stable due to resonance. Okay, so this is basically the correct answer. Okay, let's move on to the next part. Now explain why para-nitrophenol is stronger than phenol. Okay, so we already know strongest acid, right? So acidity of phenols, right? Acidity of phenol is acidity will increase if there is an electron withdrawing group, right? So we already know that NO2 group is nothing but an electron withdrawing group, right? So why para-nitrophenol is stronger than stronger than phenol, stronger acid than phenol? The reason is NO2 group is an electron withdrawing group that basically stabilizes the phenoxide ion, right? So this electron withdrawing group is going to stabilize the phenoxide. Okay, how it's going to stabilize the phenoxide? It's going to pull the electron pair. So let me just write it down. Okay, so this is basically the phenoxide ion, right? And then I have this NO2 group over here. So now what's going to happen over here is very simple. Now this is going to pull the electron towards itself. So electron density on this phenoxide is going to decrease, as a result of which you already know charge decreases, stability increases, right? So it's much stronger, right? So electron NO2 is an electron withdrawing group that destabilizes the phenoxide ion, right? Not destabilizes, sorry, it stabilizes the phenoxide ion, right? Now I mentioned 2 points of difference between phenol and ethyl alcohol. Okay, now whenever you have questions like this, you have to be a little bit extra careful to write sensible points, because they have asked 2 points. Okay, now those 2 points have to be very stronger in order for you to get the credit, right? So I'm going to write here as phenols, right? And I'm going to write here as ethyl alcohol. Ethyl alcohol. Okay. Now, let me just give you 4 points so that you can try to write down few. Phenols. Phenols are basically mild acids. Okay, so these are mild acids, whereas alcohols are neutral. Okay, and then next is phenols give violet coloration. Okay, violet coloration with neutral FeCl3, and here basically no color with neutral FeCl3. Then the next one is phenol on treatment with HNO3, concentrated HNO3. Okay, concentrated HNO3. Now this gives basically uh, picric acid, yellow PPT of picric acid. Okay, and here basically no reaction, right? No color, you can say no reaction or no PPT over here. Now the next one is with bromine water. Yes, with bromine water, right? It gives 2,4,6 tribromo derivative. Okay, 2,4,6 tribromo, and this is basically a white PPT, or you can say a pale yellow PPT, and here there is basically no reaction, right? So you can write down two sensible points from these things, and I think everything should be all right by now. Okay, so now let's move on to the next part. Yes. Okay, give the reagents and the conditions necessary to prepare phenol from chlorobenzene. So you already know this is nothing but your Dow process, right? So what are the reagents? The reagents, let me be very specific. They have asked about the reagents. The reagents are going to be NaOH, okay? And it's going to be fusion first, right? It's going to be fusion, correct? And you can say solid NaOH. And what are the conditions? 623 Kelvin and 300 atmosphere. So if you could see here, it's already there on the screen. Okay. So now this basically is the next part, and now you have give the reagents and the necessary conditions to prepare phenol from benzene sulfonic acid. Okay, so you already have the benzene, this particular reaction route which I mentioned. Now you have to be very careful, because this is just, I believe, a 1 mark question when they have just asked what are the reagents and the conditions necessary. Okay, so don't just write down all the steps and all, right? Even if you are trying to write it, make sure that your more emphasis is going to be the reagents and the condition. Okay, so here it's going to be dilute NaOH, right? Dilute NaOH, whereas here this NaOH is nothing but this is a fusion reaction which is happening over here. So this is NaOH solid, right? Correct. And you can see the temperature of this particular reaction is nothing but 350 degrees, right? So this is basically the reaction. Okay, give the equations of the reactions for the preparation of phenol from isopropyl benzene. Okay, there is one spelling mistake over here. Let me just get rid of this. Okay, so this is very much simple. What you're going to do is you're going to have a phenol, right? Not a phenol, basically a cumene molecule, right? So you have this H over here, and then there is this H, this H. Now this is going to undergo oxidation. So I'm going to write O double bond O. So let me show it in a simple way which you can understand. Now this hydrogen is going to go to this oxygen, and the bond is going to come over here. So finally, what is that which you get? Let me just shift the positions over here. So I'm going to have one here, and there is going to be O, O, H, right? So now what happens over here is a very simple. What is this? This is cumene hydroperoxide. Cumene hydroperoxide, when you strongly heat it in presence of an acid, what happens is this molecule is completely coming out, as a result of which you will be getting a phenol, right? And then you will be getting plus acetone. Correct. So this is basically the correct answer. So what are the equations that's already given, right? Just make sure to remember the names of these compounds. That's basically cumene hydroperoxide. Okay. So now the next is distinguish between ethyl bromide and ethanol. Okay. Again, very simple and very easy. It's an alkyl halide, and it's basically an alcohol, right? So the first distinguishing feature is, ethanol gives iodoform test. Okay, ethanol gives iodoform test. What is iodoform test? I hope you know. In this case, what exactly happens is you treat it with maybe iodoform and NaOH, right? Here, that's what exactly happens. Now, ethyl bromide may initially get converted into ethyl alcohol and then give the iodoform test, but that actually doesn't mean the iodoform test is going to be easier for this, because iodoform test is given by, few alcohols and even aldehydes and ketones, right? So that you already know, normally ethyl bromide is not going to give you these set of reactions. Okay. Yes, and there are other set of reactions as well that you can discuss. Ethanol ethanol on treatment with PCl3. You can use PCl3, you can use PCl5, you can use SOCl2, right? It's going to give you ethyl chloride, correct? Ethyl chloride, whereas basically there is no reaction in C2H5Br. Ethyl bromide is definitely not going to give this reaction, right? This set of reactions. So I think these are pretty much simple. You could have other reactions as well and try to explain all these. Okay, yeah. So I think that's it. So we are completely done with the part 2 for the chapter of alcohol, phenols and ethers. If you like this video, please hit the like button and make sure to subscribe and press the bell icon in order to get more periodic updates about the upcoming videos. The next video is going to be final part of this particular chapter. So stay tuned and keep watching. Thank you.